again, we want to know if this is a parallelogram or not. And so please check that you graphed it correctly. It should look like this shape there. So we want to know if it's a parallelogram, and again, we want to show essentially the same thing that we did up here, that the opposite sides are, the slopes are equal on the opposite sides so that it has parallel sides. So let's go ahead and dive in and look at its slopes. The first slope that I'm looking at is from S to P. So this looks like it goes over 1, 2, 3, 4, 5, and down 1, 2, 3, 4, 5, I believe, 7 to 2. And yep, so this goes over 5 and down 5. And likewise, let's look at the slope of RQ, which also goes down 1, 2, 3, 4, 5, and over 1, 2, 3, 4, 5. So this one goes down 5 and over 5 as well. And so we see that they both have the same slope of rise over run. So I'm going to write slope of SP equals slope of RQ. And they're both equal to that rise, or vertical over horizontal, -5 over 5. Now let's check those other slopes for PQ. If I dive in here to PQ, we're going to see that this one goes over 1, up 1, 2, 3, 4, 5. So it's over 1, up 5. And likewise, this slope here goes up 1, 2, 3, 4, 5, and over 1. And so, therefore, they both have a slope. And I'm going to write that over here. Slope of, and that was PQ, equals the slope of SR. And they're both equal to the rise, 5, over the run, 1. And so, similarly, we say the same thing as we did before. And because I'm so lazy, I'm going to come up here and copy it and paste it, but I would expect this to all be written out. It is a parallelogram. Why? Because the slopes, that's what I was showing up here and calculated over here, of its opposite sides are equal. So I showed that they were equal for these two and these two. And in the opposite sides must be parallel then. So this side is parallel to this side, and since that is the definition of a parallelogram, we can say it is a parallelogram.